Automatic, Addison.
In this tutorial, we will explore how to use structs and operator overloading in C++. So let's explore how to work with structs in C++ and their application in robotics projects. Structs can be used in C++ to group related data together, making the code more organized and readable. Structs are particularly useful in robotics projects for representing various data structures such as robot configurations, sensor readings, or control parameters. So we have a terminal window open, and let's go to our favorite folder here, Documents, CPP Tutorial, and we'll open Visual Studio Code. Create a new C++ file named robotstruct.cpp. Right-click, new file, robotstruct.cpp. And let's add the following code. We'll do our includes as we always do. #include, iostream, #include, string, struct, robot spec, stood string model, int max speed, and double weight. Let's go down, void. Oh, we need our semicolon. And I'll explain all of this in just a bit. We're going to go print robot spec, const robot spec, and let's do stood cout model spec.model, and then stood end L. Next line, stood cout max speed spec.max speed. Say meters per second. And let's go over here and do stood end L. All right, and let's do stood cout weight spec.weight kg, and stood end L. Int main robot spec robot, do mobile bot, and we'll do comma 5, comma 10.5. Close all that out with our semicolon, and let's do print robot spec robot, return 0. Does everything look good so far? So what did we do in this code? In this code, we define a struct called robot spec to represent the specifications of a robot. It contains 3 members: model, which is a string, max speed, which is an integer, and weight, which is a double. We also define a function called print robot spec that takes a constant reference to a robot spec object and prints its members. In the main function, we create an instance of the robot spec struct called robot and initialize its members 1, 2, and 3. We then pass robot to the print robot spec function to print its specifications. Now let's run the code And when you run it, you can see the output displays the robot specifications as defined in the robot spec struct. Now let's explore the concept of operator overloading in C++ and its applications in robotics projects. Operator overloading is a powerful feature in C++ that allows you to define custom behavior for operators when applied to user-defined types. This means you can make operators like plus, minus, multiply, divide, and others work for your own classes and objects in a way that makes sense for your specific use case. Let's create a new C++ file. We're going to call it distance.cpp and type the following into the code editor. #include iostream, do public int meters, distance int m equals 0, meters, curly braces, distance operator plus const distance ampersand other const open curly braces, say return distance meters plus other dot meters. Is everything good? See const, close that. Oh, forgot to declare the class. Distance. There we go. Class distance, meters, distance, meters. Here's our operator with the plus sign. And now let's do the main function, int main. And we're going to do distance d1, 5, distance d2, 10. And let's do distance sum equals d1 plus d2. So stood, see out, d1 equals d1 dot meters, meters, do stood in line, and let's just copy this so I don't have to keep typing. Let's go here, 2 and 3, and on this line we're going to do d2, and let's do sum. Let's do d2 here, and let's do sum. Meters, 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 and then at the bottom we'll do return 0. Everything all good. Okay, so what do we do in this code? In this code, we define a class called distance to represent a distance in meters. We overload the plus operator by defining the operator plus, this operator plus here, member function. This function takes another distance object as a parameter and returns a new distance object that is the sum of the two distances. So in the main function, we create two distance objects, d1 and d2, and we compute their sum using the overloaded operator. We then print the distances and their sum using the meters member variable. Now let's run the code. And here we go with our output. Let's bring this up so you can see it in all its glory. D1, D2, D in sum, D1, D2, and the sum. So the output displays the distances, D1 and D2, as well as their sum in meters. So by overloading the plus operator, we've made it possible to add two distance objects together using the familiar syntax D1, D1 plus D2, which makes the code more intuitive and readable. So, how does this relate to robotics projects? Well, in a robotics project, operator overloading can be useful for performing operations on custom data types, such as distances, angles, or time durations, making the code more expressive and easier to understand. That's it for this tutorial. Thank you for watching, and I'll see you in the next tutorial. Keep building.